In this video, let's take a look at Cosmos DB's request units. And we'll begin by understanding what is a request unit. A request unit is a rate-based currency that provides a logical abstraction over all of the physical resources it takes to perform a database request. So every time a request comes into the database, it's going to use some CPU, memory, and I/O, and Cosmos DB will normalize this together across one single dimension called the request unit so that you have one knob for conveniently scaling up and down the throughput for your set of Cosmos containers. The request unit is the basis for providing resource governance in Cosmos DB, which in turn allows Cosmos DB to provide performance isolation in a multi-tenant environment, bringing the total cost of ownership of a distributed database to something very low. In addition to that, the resource governance is implemented at a very fine granularity at a per request basis. And this is the means for Cosmos DB to provide predictable performance and SLAs around latency and throughput. Cosmos DB uses the concept of a request unit instead of a request because not every request uses the same amount of resources. A database read, depending on the consistency level, might get routed to a replica and just pluck a value out and return it. Meanwhile, a database write will have to generate index terms as well as replicate to additional database replica. And so Cosmos DB normalizes a request unit to be equivalent to a point read of a 1 kilobyte record. Every request you make is going to cost a fixed amount of RUs. And what's interesting here is Cosmos DB actually uses machine learning to provide a logical stable charge behind the scenes. And that way, every time you run a, uh, let's say a particular request, if you run the same request exactly over and over, what you'll see is a very flat, stable charge that is very predictable. And this allows you to do capacity planning by performing simple mental math. So for example, if I need to do 100 database operations per second, and I know that each operation is about 2 request units, then I can just do the mental math of 100 times 2 is 200 request units per second that you need to provision. Generally speaking, a, uh, a database write is going to be proportional to the number of index entries it needs to generate, as well as the number of bytes for the record. And for queries, the number of request units is going to be highly proportional to the number of query results because at the end of the day, that's going to be proportional to how much I/O the underlying system needs to perform. So Cosmos DB uses this request unit concept and builds a provisioning model in which you're going to provision a set number of request units per second. And you can think of this similar an analogy to a token bucket system in which you have a token bucket that has tokens replenished, and the size of the bucket and the rate of replenishment is proportional to the amount of RUs per second you have provisioned. And each time you perform a database request, a few tokens gets consumed. And if the token bucket becomes empty, the next time a request comes in, what will happen is called rate limiting. Basically, that request will be asked to retry after a small amount of time once the bucket has more tokens. You can increase and decrease the amount of provisioned RU per second instantaneously, either through the Azure portal or through any of the SDKs. And Cosmos DB bills your provision throughput on an hourly basis so that you can scale up, scale down, and pay for only what you need. So for example, if you have a workload that is hot from the hours of 9 to 5, what you can do is you can scale up your containers from hours 9 to 5 and scale them down during after hours. Let's walk through a quick pricing example to get an understanding on how you can translate request units to get a estimated cost for how much your Cosmos DB instance will cost you. And what we'll do is we'll look across our pricing example here across two dimensions. One is storage, the other is throughput. I should also mention here that the pricing does vary per region, and over time we also, generally speaking, lower these costs. So if you want to get an understanding of the most up-to-date pricing, please visit the website at azure.com, or sorry, azure.microsoft.com/pricing/details/cosmos-db. Okay, so looking at storage costs first, let's say we have a good understanding of what a sample record, what a typical record we're storing in the system looks like, and it happens to be a 1 kilobyte record. And we also know that we need to store about 100,000 of these. So if I do a kilobyte multiplied by 100,000, what you'll see here is that'll be 100 gigabytes. And at least for this point in time, at the region I'm looking at, the monthly cost per gigabyte is 25 cents per gigabyte. And so if I multiply 100 gigabytes by 25 cents per month, I'm going to get about $25 per month for storage. For throughput, what you'll want to do is get a estimate for how many request units it takes to perform any individual database request. And so what you'll want to do is a sample create, read, update, delete, and query. And for here, to simplify our model, we're just going to look at creates and reads. And so what we found here is when I do a database create, it costs about 5 request units. And when I read that record back, it costs about 1 request unit. And if I know that I have to concurrently run 100 creates per second along with 400 reads per second, what we can do is we can multiply the 100 creates per second by 5 request units per create. So that'll be 500 request units per second for the creates, and then 400 multiplied by 1 is 400 request units per second for the reads. If I sum these together, I know that I need 900 request units per second to maintain this concurrent workload of about 500 requests per second. And when I check the pricing sheet, I also see that for every 100 request units per second, that'll cost about $6 a month. And so if I look at 9 times 100 RUs per second, so 9 times $6 a month, that'll come out to be about $54 a month. And so if I add the monthly cost of storage with the monthly cost of throughput, I now have the estimated total monthly cost of this Cosmos DB instance. This concludes our video on request units. Thank you for watching.